Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of limits and in today's video we will see how to find the limits using some standard expansions. Okay, expansions are very important. If you remember the expansions, certainly you will get the answers in most of the questions which contains trigonometric functions, exponential functions and also logarithmic functions. Okay, now expansions are very important, keep this in mind. If you do remember these expansions, okay, now I just wrote 3 expansions here. There are around some 8 to 9 expansions which you must remember. If you remember them, you can easily solve all those questions. Just like that you will get the answers. Okay, now I'll just introduce Maclaurin series. Actually he is not there in the syllabus, but still I'll just give you Maclaurin, what is Maclaurin series and how to use it to prove any one expansion. Okay, now I'll just use the Maclaurin series to prove any one expansion and you can prove the remaining expansions using this Maclaurin series. Okay, and after giving all the expansions we'll start solving problems based on this concept. Okay, let us start. Okay dear students, let us see what is Maclaurin series. Series means sum of terms. Okay, now see f of x, any function f of x whose derivative can be found, which is differentiable, whose first derivative is possible, whose first derivative exists, second derivative exists, third derivative exists and so on at x is equal to 0. If that is the case, we can use Maclaurin series to find the expansions of certain functions. I know that we didn't learn differentiation as of now. Okay, now but if you must have some basics of differentiation. You should know sin x derivative, you should know cos x derivative. Like this, some basic function derivatives must be remembered if you want to solve all the questions in limits. Okay, now so you try to remember the derivatives of basic functions. Using that, let us see how to prove the expansions. Okay, 1 or 2 expansions I'll prove it and you can by heart the remaining. Okay, you must by heart the expansions. First let us see how to find what is the expansion of sin x. Already I have written just before. Let me prove how to find the expansion of sin x and remaining functions we are not proving it. You can directly by heart them. Okay, to find sin x we should know what is f of 0, what is f dash of 0, what is f double dash of 0, what is f triple dash of 0 and so on. First of all, f of 0. If f of x is sin x, dear students, if f of x is sin x, first let me find the derivatives. The first derivative f dash of x is sin x derivative. You will remember, you have to remember sin x derivative will be cos x. Let me take derivative once again. Okay, now so if I take derivative once again, I'll get f double dash of x, the second derivative of f of x, which is cos x derivative. Cos x derivative will be minus sin x. Let us find one more derivative, f triple dash of x, the third derivative of f of x, which is minus as it is, and we just learned that sin x derivative is cos x. Just know these 4 functions. Now we are supposed to find f dash of 0, f double dash of 0, f triple dash of 0, correct or not? So from this, what is f of 0? F of 0 is equal to sin 0, which is 0. Next, f dash of 0, f dash of 0 is what? Cos 0, which is 1. Next, f double dash of 0, f double dash of 0 means minus of sin 0, which is again 0. Next, f triple dash of 0, which is minus cos 0. F triple dash of 0 is minus cos 0. Cos 0 is 1. So f triple dash of 0 is minus 1. Now substitute those values. F of 0 is 0 plus f dash of 0 is 1. So 1 by 1 factorial into x. Next, f double dash of 0 is 0. No? So plus 0 by 2 factorial into x square. And then f triple dash of x is what? Minus 1. So minus 1 by 3 factorial into x cube and so on up to infinity. Okay, now therefore what is the expansion of sin x? So sin x is equal to x minus x cube by 3 factorial. Okay, now and if you find the fourth derivative of f of x, if you find the fourth derivative of f of x and fifth derivative of f of x, you will get one more term. You can check what is it. I'll write it directly. That one more term will be x power 5 by 5 factorial minus and so on. So how do we remember this? So sin x expansion will be what? See, observe, sin x is a odd function, if you know it or not from the chapter of functions. It contains the terms of x whose powers are only odd numbers. Whose powers are only odd numbers. X power 1, x cube, x power 5, next it will be x power 7 and so on. And let me write the expansion. First term will be x by 1 factorial. It is positive. Next, minus x cube by 3 factorial. This is negative. Next, plus x power 5 by 5 factorial. This is positive. Next, minus x power 7 by 7 factorial. This is negative. Next, x power 9 by 9 factorial, and so on up to infinity. You can keep writing the terms if needed. Okay, now observe, the power of x is 1 and the denominator is 1 factorial. The power of x here is 3 and the denominator is 3 factorial. The power of x is 5 and the denominator is 5 factorial, and it goes on like this. The first term is positive, the next term is negative. Positive, negative, positive, negative, and so on. Okay, now this is the expansion of sin x. Similarly, you can try proving the remaining expansions using this Maclaurin series, but proving is not there in our syllabus of JEE, so we'll go with the expansions which we are going to use now to solve the problem. So I'll write the expansions as homework. You can try proving 1 or 2 expansions. Okay, now so I'll write the expansions. Let us by heart each and every expansion. Okay, but in case if you forget the expansions, we always have Maclaurin series. This is easy to remember. Maclaurin series is easy to remember, but you should know derivatives. Okay, now if you remember Maclaurin series, automatically you can find the expansions of whatever I'm writing now. Fine, let me write all the expansions which we are going to use. Okay, log of 1 plus x expansion is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on up to infinity. Observe, it contains all the powers of x starting from x power 1, x power 1, x square, x cube, x power 4 and so on. X denominator is 1, x square denominator is 2, x cube denominator is 3, x power 4 denominator is 4 and so on. First one is positive, next negative, positive, negative and so on. But students will confuse when they are doing the questions now. Instead of taking 2, 3, 4 as denominators, they will mistake as 2 factorial, 3 factorial, 4 factorial. Be careful there. In the expansion of log of 1 plus x, the denominators are not factorials, they are just numbers. Okay, now it's easy to remember. All these are easy to remember only. And next, one thing is important. While using the expansion, this value of x is there, right? It must be between minus 1 and plus 1. And most importantly, x should not be equal to minus 1, because if x is equal to minus 1, if x is equal to minus 1, I'll get log of 1 minus 1. Log 0 is not defined. So x is not equal to minus 1. Same way here also, x is between minus 1 and plus 1, and x is not equal to 1. It can be equal to minus 1. And how do we get log of 1 minus x expansion? Very simple. In the first expansion, instead of plus x, we have taken minus x. Now, in RHS also, in place of plus x, you substitute minus x. So x means minus x. Okay, now next, minus x whole square is x square. That's why this sign is not changed, because minus x whole square is x square only. The sign is not changed. And minus x whole cube means you'll get minus. Minus x whole power 4 is x power 4 only. The sign is not changed. Okay, now so log of 1 minus expansion, all are negative terms until infinity. Each expansion contains infinite terms. Okay, now next, a power x expansion, 1 plus x by 1 factorial into log a base e plus x square by 2 factorial into log a base e whole square plus x cube by 3 factorial into log a base e whole cube and so on. Observe, power is same as power is 2 means the denominator is 2 factorial and log a base e power is 2. Here power is 3 means the denominator will be 3 factorial and log a base e power will be 3 and so on. Okay, now so I hope you know what is the next term. What is the next term here? X power 4 by 4 factorial into log a base e whole power 4 and so on. Okay, now next, in this expansion of a power x, instead of a, if I take e, the irrational number e, which is approximately 2.71, instead of a, if I take e, what happens? I'll get log e base e. Log e base e is 1, correct or not? So this will be 1, this will be 1, this will be 1 and so on, and we will be copying this expansion. 1 x by 1 factorial into 1, x square by 2 factorial into 1, x cube by 3 factorial into 1 and so on. E power x expansion is very easy to remember. Na? 1 plus x power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. Next, if you remember e power x, you can also recreate e power minus x. How? By replacing x with minus x in the right side. X means minus x. X means minus x. Minus x whole square will be plus x square only. X means minus x. Minus x whole cube will be minus x cube. Okay na? And here you will get plus. Okay na? Because minus x whole power 4 is plus x power 4, right? So alternatively positive, negative, positive, negative, positive, negative and so on. So I have written 5 expansions here and 3 more expansions are there that we must remember. Sin x expansion, cos x expansion and tan x expansion. So after noting down, we will start solving the problems. Do note these expansions and do by heart them. Do remember it. Very, very important expansions. Okay, sin x expansion as I have already proved. Okay, now how do we remember? Sin x is a odd function. It contains only odd powers of x. X power 1, x cube, x power 5, x power 7 and so on. X power 1 denominator is 1 factorial. X cube denominator is 3 factorial. X power 5 denominator is 5 factorial and so on. Positive, negative and so on. Okay, now. And similarly, cos x is a even function, correct or not? It contains terms with only even powers of x. So this is x power 0, which means 1. X square denominator is 2 factorial. X power 4 denominator is 4 factorial. X power 6 denominator is 6 factorial and so on. And alternatively, plus sign and minus sign, plus sign and minus sign and so on. But tan x, this is something difficult because we will easily get confused and we will forget the expansion of tan x. But still, you have to by heart. There is, because even if you use Maclaurin series, the proof of tan x expansion is very lengthy. Okay, now the best way is to by heart it. Okay, and remember tan x is again odd function, right? Only odd powers of x will be there. X power 1, x cube, x power 5 and so on. Next term is x power 7 itself, but I don't know what is the coefficient, and proving is also difficult. You know, if you try proving it using Maclaurin series, you will understand the difficulty. You have to by heart this. Okay, now so x plus x cube by 3 plus 2 by 15 into x power 5 plus and so on. 3 terms, minimum 3 terms. If you remember, it would be fine. So I have written total 8 expansions. In some books, we will also find the expansions of sin inverse x, cos inverse x and tan inverse x. If needed in problems, I will give it, but most probably we will not use it. Okay, now. So fine, let us use these 8 expansions to solve as many questions as possible using expansions. We'll start with the first question. Here is a first question, which is a simple question. So before starting it, first of all, go with direct substitution. Substitute x as 0. You'll get sin 0 minus 0 minus 0 cube by 6 divided by 0 power 5. So it is in the form of 0 by 0. Okay, now. So first of all, let us see how to solve this question using expansions. Since you know the sin x expansion already, dear students, write at least 3 terms of sin x. The first term is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. Enough, 3 terms are enough. Okay, now. Because the denominator is x power 5 na, if you write up to x power 5, it is enough. If you are interested, you can write one more. You can write one more if needed. Let us write one more term. Minus x power 7 by 7 factorial and so on. And 2 more terms are there. What are that? Minus x cube by 6 whole divided by x power 5. Okay, dear students, plus x and minus x cancels. Minus x cube by 6. I'm sorry, this is plus here. Okay, now a small change in the question. This is plus x cube by 6. Make a change. Okay, so minus x cube by 6 and plus x cube by 6 also will get cancelled. Okay, now observe one thing. The numerator's least power of x is x power 5 and the denominator's least power of x is x power 5. This least powers of x are very, very important in upcoming questions, particularly when we are using limits using expansion. What is the least power of x in the numerator and what is the least power of x in the denominator after simplification? These two are most important. Remaining are not needed. Okay, fine. Now x power 5 is a common denominator. We can separate it to all terms. What will you get? Limit x approaches 0. X power 5 by 5 factorial divided by x power 5. So you will get 1 by 5 factorial. Correct? X power 7 divided by x power 5. What is it? Minus as it is. X power 7 by x power 5 is x square. In the denominator we have 7 factorial. If you write one more term na, it will be x power 9 plus x power 9 by x power 5. X power 9 by x power 5 will be x power 4 plus with denominator 9 factorial. I'll tell you why other terms are not needed. See, the least power of x is here x power 5 and least power of x is x power 5. They are matching and remaining terms are not needed in this expansion. You will understand why. Why remaining terms are not needed means, if I substitute x as 0, what happens? I'll get only 1 by 5 factorial. 0 square minus 0. 0 power 4. 0. Even if you write the remaining terms, dear students, those terms will become zeros. They are not needed. That's why, okay, now what's important for us is, if the least power of x here and least power of x here is matching, then automatically the remaining terms are not needed, because finally they will become 0, 0, 0 and so on. By practice you will understand what I am saying. The answer is 1 by 5 factorial. Okay, now 1 by 5 factorial, and you can calculate what is the value of 1 by 5 factorial. It is 1 divided by 120. So that is the answer for first question. Okay, now you can try this question. Try this. What is it? Try to find the value of limit x approaches 0 sin x minus x divided by not x square. It is x cube. Find the answer for the second question. This is second question, and let me know what is the answer in the comment sections. Okay, we will go with next question. See, first question is basic question only na? I just wrote the expansion of sin x and I got the answer. We will go to next question. Here is our second question. Limit x approaches 0, x cos x minus log of 1 plus x by x square. Okay now, so log of 1 plus x expansion can be used only when x is between minus 1 and plus 1. The value which x is approaching is 0. It is between minus 1 and plus 1, right? We can use the expansion. Okay, let me solve this question using expansions of cos x and log of 1 plus x. So dear students, x into cos x expansion, if you remember, 1 minus x square by 2 factorial plus x power 4 by 4 factorial, and remaining terms are not needed. I'll simply keep and so on. Minus, open the bracket, log of 1 plus x expansion is x minus x square by 2 plus x cube by 3 and so on. When you are starting these questions now, remembering expansions might be difficult, but as you keep practicing, you will remember it. Okay, now dear students, if you expand, what happens? Limit x approaches 0, x is multiplied with all the terms. X into 1 is x minus x into x square, x cube by 2 factorial plus x into x power 4, x power 5 by 4 factorial and so on. Minus into x is minus x plus x square by 2 minus x cube by 3 and so on. Whole divided by x square. What gets cancelled? Plus x and minus x gets cancelled. Next, dear students, what is the least power of x in the numerator? X square. And what is the least power of x in the denominator? X square. And remaining terms, even if you write also, they won't be mattering much in the final answer. Why means you will understand. See, limit x approaches 0. This is the only x square term. X square by 2 divided by x square. I am separating the common denominator. X square by 2 divided by x square is 1 by 2. Correct? Next, here minus x cube by 2 divided by x square. What is it? Minus x by 2 factorial, which is 2. X power 5 by x square is x cube divided by 4 factorial and so on. Minus x cube by 3 divided by x square. Minus x cube by x square is minus x divided by 3 and so on. What we are substituting here, x as 0 only, which means this term is gone, this term is 0, this term is also 0. All the remaining terms are 0 only. Are you understanding this? See, once again I am repeating, what is the least power of x in the numerator? X square. What is the least power of x in the denominator? X square. Except these two, okay now, the remaining terms in the numerator, they will become automatically 0. I hope you understand this. So we are getting only 1 by 2 as the final answer. Therefore, dear students, using the expansions, we got the answer as what? 1 divided by 2. Okay, next we will go with the third question. So here is our third question. So before solving it, substitute x value as 0 and see in what form it is. 1 by 0 infinity minus cosecant 0 is infinity. Correct? But cosecant 0 is what is it? Cosecant 0, 1 second. Cosecant 0 is not defined, but if you take cosecant x in the denominator, what does it become? Sin x. Correct or not? So 1 by sin x. Now if you look like this, 1 by 0 into 0, infinity. Okay, it is in what form? Infinity minus infinity form. I'll rewrite like this. Okay, now, so anyhow, actually to say when x is approaching 0, cosecant, yeah, fine, it's okay, nothing wrong in this. Now let us see how to solve this question. Fine, limit x approaches 0. Let me see how to simplify it. 1 by x square minus, we don't remember cosecant x expansion, we remember only sin x expansion. So what I'll do is take cosecant x to the denominator, 1 divided by x into sin x. Correct? Now let me take common denominator. Here x square is there, here also I want x square, so into x and into x. Here sin x is there, here also I want sin x, so into sin x and into sin x. So what happens to the question? Limit x approaches 0, we have got common denominator x into x, x square sin x. The common denominator is x square sin x and the numerator is sin x minus x. Now substitute the expansion of sin x, you will get the answer just like that. Over. Limit x approaches 0, sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. Remaining terms are not needed, you will understand why. Whole divided by x square into sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on, infinite number of terms. Now dear students, if you observe in the numerator, plus x and minus x gets cancelled, and after cancellation, dear students, what is the least power of x in the numerator? X cube. Here if I take x common in all the terms and if I take x common outside, see what happens. Limit x approaches 0, what I will do is I will take x cube common in every term. X cube if I take common in every term, what I will get? Minus 1 by 3 factorial plus, so what is it? X square by 5 factorial and so on up to infinity, whole divided by, I'll take x common in all these terms, x will come outside, this becomes x cube into 1 minus x square by 3 factorial plus x power 4 divided by 5 factorial and so on up to infinity. So x cube and x cube will get cancelled automatically. In the remaining terms you can substitute x as 0, then what happens? Only minus 1 by 3 factorial, that means minus 1 by 6 will be remaining. This term will be 0, if there is next term that will be 0 and all the remaining terms will be 0 because you are substituting x as a 0. So I told you the remaining terms does not matter. The least power of x after cancellation in the numerator is constant, x power 0. The least power of x in the denominator is another constant, x power 0. Remaining terms automatically they will become 0. So minus 1 by 6 in the numerator divided by 1. Minus 0 plus 0, all these are not needed. So therefore dear students, the final answer is minus 1 by 6. The answer for this question, limit x approaches 0, 1 by x square minus cosecant x by x is equal to minus 1 by 6. Using expansions we got the answer. Okay, we'll go with next question. So our next question, limit x approaches pi by 2, e power cos x minus of 1 plus cos x divided by tan of cos x whole square. What is this? Everywhere cos x, cos x, cos x and so on. Yes, of course, I will do something with cos x. But before that, if I substitute x as pi by 2 in the question, cos pi by 2 is 0. E power 0 is 1. So cos pi by 2 is 0. The numerator will be 1 minus 1, which is 0, divided by cos pi by 2 is 0 and tan 0 is 0. So the question is in what form? 0 by 0 form. Before you do something, first of all check whether we are getting a finite answer or not while substituting x value. Because if you get a finite answer when you substitute x value, that is the final answer. In case if you are getting any indeterminate form, then we should do what to do in this particular question. Okay, now dear students, fine. As I told you, there is cos x everywhere. Now we will do something with cos x. Let cos x is equal to y. Let cos x is equal to y. Okay. Now dear students, as x is approaching pi by 2, then cos x is approaching cos pi by 2. As x is approaching pi by 2, cos x is approaching cos pi by 2. So what is cos x here? Y. Approaching cos pi by 2, 0. So what I am going to do is, I will change the question now. Now the question is rewritten as limit. Instead of writing x approaches 90, I will write y approaches 0 instead of writing that. And e power, instead of cos x, I will write y. Minus of 1 plus. Instead of cos x, I will write y. Whole divided by tan y whole square. Correct or not? Which means tan, okay fine, tan y whole square. Now the question looks simple instead of cos x. So I just replace it when x is replaced with y. Okay, now let us see how to simplify this question. Using what? Expansions. Can you try it before I explain? Pause the video, try it and check whether you got the answer or not. And then those who want the explanation, listen. So I just changed the question. So I am erasing this part. But this must be shown in the solution if it is descriptive. Okay. So let us continue by substituting the expansions. So limit y approaches 0 and e power y, it is not e power x, it is e power y. What is the expansion of e power y? 1 plus y by 1 factorial plus y square by 2 factorial plus y cube by 3 factorial and so on. If needed, I will write the remaining terms in the next steps. Okay, now minus 1 minus y, correct or not? Minus 1 minus y. Children, what they will do, they will write minus 1 plus y in urgency. They will not use distributive property. Please understand, minus is for both the terms. Okay, whole divided by tan y's expansion. You must remember tan y's expansion. You should repeatedly practice to remember. What is it? X plus x cube by 3 factorial, not 3 factorial, I'm sorry, x cube by 3 plus 2 by 15 into x power 5 and so on. Observe one more thing. What children will do is, they will write plus minus plus, but tan x expansion is not plus minus plus. All these three terms are positive. Okay, now remember this. And tan x expansion contains only odd powers of x. The more you use, the more you remember. Now dear students, I made a mistake as usual. Instead of, I should have written y here, correct or not? Because the variable is y. Tan y is y plus y cube by 3 plus 2 by 15 y power 5 and so on. Dear students, I forgot whole square. You don't forget it. Tan y whole square plus y plus 1 minus 1 will get cancelled. Plus y minus y also gets cancelled. Now what is the least power of y in the numerator? Y square. What is the least power of y in the denominator? Do not say y, it has whole square. Correct or not? Y square only. So I'll do one thing. Let me take y square common in the numerator and y common in the denominator. Limit y approaches 0. I took y square common in the numerator. What is it? 1 by 2 factorial plus y by 3 factorial plus and so on, whole divided by. In each term I took y common, and when y comes out of this bracket, it takes the power. So y square into 1 plus y square by 3 plus 2 by 15 into y, what is it? I took y common, right? Y power 4 and so on, whole square. So y square gets cancelled. You can substitute y value as 0, and what answer will you get? Since y value is 0, all the remaining terms will become 0. Okay, now only 1 by 2 is remaining in the numerator. Here, this is 0, and all other terms are 0. Only 1 is remaining in the denominator. So 1 by 2 is your final answer. Once again, I am repeating. The least power of y in the numerator is y square. The least power of y in the denominator is also y square. Okay, now except those two, the remaining terms are negligible because they will automatically become 0. So sometimes I can directly write the answer. By practice, you will also write the answer directly. After getting this step, we can skip this step. And what is the answer directly? Y square coefficient divided by y square coefficient. Y square coefficient 1 by 2 divided by y square coefficient 1. So 1 by 2 by 1, 1 by 2. Directly you can write that step if you understand this. Okay, we'll go with next question. Very, very important model. These kind of questions we have to find as many as possible, and we have to practice them, these kind of models. Okay, now come back to the question. What they told is, if this limit is finite, understand this, if this limit is finite and equal to L, that means what? The limiting value of this function is equal to L. Okay. Then they told us to find the value of the unknowns a comma b comma L. Okay now. So okay, fine. What they told is that the limiting value of this function is finite and it is equal to L. Okay now. So this value is L. So they told that this is a finite number. Then we have to find the values of a, b and L. So as usual, let us use expansions to simplify this question. Limit x approaches 0. Cos 2x. See, cos x expansion you know. Then same way you can write cos 2x expansion. What is it? 1 minus 2x whole square by 2 factorial plus 2x whole power 4 by 4 factorial and so on. Dear students, cos x expansion is what? 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. Instead of x we have what? 2x. So instead of x we are writing what? 2x. Instead of x we are writing what? 2x. That's it. Okay now. So same way plus, okay, close it inside the brackets, plus a into, similarly what is cos 4x expansion? Instead of x we will write what? 4x everywhere. So what is it? 1 minus 4x whole square by 2 factorial plus 4x whole power 4 by 4 factorial minus and so on, and do not forget plus b, okay, that is the numerator, whole divided by x power 4, this is the denominator. Okay dear students, let me erase this. Now let me rewrite it. First let me write constant term in the numerator. Okay, limit x approaches 0, 1 plus a into 1 is plus a plus b. So these three are, this is constant term in the numerator's expansion. Next we will get x square term, correct or not? What is x square term? Please observe. Minus 4x square by 2, minus 4x square by 2, and here minus a into 16x square by 2, minus a into 16x square by 2. So these two are x square terms, correct or not? Next we also have x power 4 terms. What are x power 4 terms? Plus 2 power 4 is 16 x power 4 divided by 4 factorial, and next a into this one, what is it? Plus a into 4 power 4 into x power 4 divided by 4 factorial. Only these two are x power 4 terms, and all the remaining terms are what terms? They are x power 6 terms. Okay now let me write something into, you will get something into x power 6 plus something into x power 8 and so on. They are, I don't want the remaining powers of x. Y means you will understand. You will understand slowly. Whole divided by x power 4. Actually dear students, if you write one more term here and so on, if you write one more term here and so on, it will be something into x power 6. Okay now, but not needed, but you will understand why. Now let us start analyzing this. Dear students, imagine this, that this number is not 0. Maybe this number is 2. Okay now, then when I separate the common denominator, you will get 2 divided by x power 4, correct or not? And x approaches 0 na, then 2 by 0 will be infinity. Infinity plus or minus whatever it is, the answer will become infinity. When the answer becomes infinity, when this entire answer will become infinity, if this number is not 0, if 1 plus a plus b is not equal to 0, then the entire answer becomes infinity. Just now I have explained why it becomes infinity. So for that reason, if you want a finite answer, this term should be equal to 0. This term, who is it? 1 plus a plus b should be 0. Same way dear students, this is x square term, correct or not? This is x square term. This is x square term. If I take x square term divided by x power 4 term, what will you get? Something divided by x square. If that something is not 0, something divided by x square will come. If that something is not 0, if it is some other number, even this term will give you infinity. Maybe for example 2 divided by x square, x is approaching 0, 2 divided by 0, then this term will become infinity and the entire answer becomes infinity. But the answer is finite. What is the meaning of it? It means that the coefficient of x square also should be 0. The coefficient of x square also should be 0. It should be 0 into x square. Okay, na? And the next term is x power 4. Here also we have x power 4. X power 4 coefficient need not be 0. Once again, let me make it simple for you to understand. What is the power? What is denominator? Least power of x in the denominator, x power 4. Then the least power of the numerator also must be x power 4. The least power of denominator also must be x power 4. If you have x cube, its coefficient must be 0. If you have x square, its coefficient must be 0. If you have x term, its coefficient must be 0. If you have constant, that must be 0. Are you understanding? Once again, let me repeat. If the least power of x in the denominator is x power 4, then the least power of x in the numerator also must be x power 4. And if you have any other lesser powers of x, their coefficients must be 0. Now are you understanding what we are doing? Okay, na? So therefore x power 4 term should be there, x square term should not be there, constant should not be there, which means x square coefficient must be 0, constant must be 0. Now let us use this fact to find a value and b value. So dear students, for this reason the constant will be 0. 1 plus a plus b should be 0, which means a plus b should be minus 1. Next, what is x square coefficient here? This is minus 2x square. And this is minus 8ax square. Minus 8ax square. So which means minus 2 minus 8a into x square. So x square coefficient is minus 2 minus 8a. This also should be 0. Minus 2 minus 8a should be 0. Or minus 2 is equal to 8a. From this, dear students, you will get a is equal to minus 2 divided by 8, which is minus 1 by 4. I got a value. Now substitute this a value in this equation. You will get b value. So what is it? A plus b is minus 1. A is minus 1 by 4 plus b equal to minus 1. B is equal to, take minus 1 by 4 to the right side, you will get minus 3 by 4. We got a value and b value. So dear students, a value is minus 1 by 4, b value is minus 3 by 4. And I should also find the value of L. Na? How do we get the value of L? The value of L is what? X power 4 coefficient in the numerator divided by x power 4 coefficient in the denominator, because the remaining terms automatically become 0 when you substitute x as 0. Okay, now once again, how do we find the value of the limit? The limit is what? Now this is 0, this is 0. The limit is x power 4 coefficient in the numerator divided by x power 4 coefficient in the denominator. So see, I removed constant term and x square term because their coefficients are 0. Now what is L value? The limit is equal to x power 4 coefficient in the numerator. What is it? 16 by 4 factorial. 16 by 4 factorial is 24. X power 4 plus 4 power 4 is 256. Okay, na? A into 256 divided by 24 into x power 4. The denominator x power 4. The remaining terms will be 0 because x power 6 by x power 4 is x square and x value is 0, na? X approaches 0, that will be gone. Okay, fine. With limit x approaches 0. Take x power 4 common and cancel it. So L is equal to what? 8 2s are 8 3s are plus both are divisible by what? 8. 8 3s are and 8 3s are 2s are. What will you get? A into 32 by 3. That is L value, the limit. And you can substitute a value which you have got. A value is how much, dear students? Minus 1 by 4. Substitute a value, will get the answer. So L is equal to 2 by 3 plus a value is what? We just got minus 1 by 4 into 32 divided by 3. 4 1s are 4 8s are. The common denominator is 3. The numerator is 2 minus 8, which is minus 6. The answer is minus 2. Therefore, dear students, the value of this limit is minus 2. So we got a value minus 1 by 4. We got b value minus 3 by 4. We got limit which is equal to minus 2. Okay, now, and one more question, sixth question. Okay, it is an application of what you have understood in all the 5 questions. So that is the last question. But before that, I will give you one question which is like this model. You can try it and you can find the values of a comma b comma l. I'll write that question, you can try it. So this is the sixth question, you can try this. Okay now, so find the values of a comma b using expansions, just like the previous question. This is very easy. Okay, so we'll go with next question. So here is the last question in the video. They told us to find the integral value of n for which this limit is finite non-zero number. Okay now, fine. So before starting the solution, let me simplify the first four terms using factorization. Please observe. If you observe the question carefully, if you study the question first carefully before directly jumping into solution, first observe the first four terms can be factorized. How can I factorize it? In these two I can take cos x common into cos x minus 1, and in these two I can take e power x common and at the same time minus e power x common. I will take minus e power x common. Minus e power x went outside, we have cos x. Minus e power x went outside, we have minus 1. Okay now, so here and here we have cos x minus 1 into cos x minus e power x. So dear students, the factorized form of these four terms is cos x minus 1 into cos x minus e power x. Let me substitute that. So if I substitute that, the question becomes what? Limit x approaches 0 cos x minus 1 into cos x minus e power x, and then we also have minus x cube by 2 whole divided by x power n. Now let us substitute the expansions of cos x and e power x and let us see what happens. Limit x approaches 0, cos x expansion is 1 minus x square by 2 factorial plus x power 4 by 4 factorial, enough, and so on. Minus 1, don't forget that, into, again cos x expansion is 1 minus x square by 2 factorial plus x power 4 by 4 factorial, and so on, minus, open the bracket, e power x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on, close it, and then we do not forget minus x cube by 2 in the numerator whole divided by x power n. Now let us see that plus 1 and minus 1 gets cancelled here, plus 1 and minus 1 gets cancelled here, and observe, yes, that's it, no more cancellations in the numerator. Okay now dear students, limit x approaches 0. What do we get next? This is what we are supposed to study. Please listen carefully, dear students. I am going to multiply these two. This is not sum of, this is product of, correct or not? I am going to study what is the least power of x possible. First of all, in this expansion we have minus x. That is the least power of x in this expansion. And x square is the least power of x in this expansion. If I multiply minus x into minus x square by 2 factorial, what do we get? Minus x into minus x square by 2 factorial, minus into minus plus, x into x square is x cube divided by 2 factorial, and outside who is waiting for us? Minus x cube by 2. They will get cancelled. That means, so when I multiply minus x with this person, when I multiply these two, I got least power of x as x cube, but that x cube and this x cube will get cancelled. Next, now this person is gone, he is gone. Okay now what is the least power of x? We have to find what is the least power of x. Please observe, you can still take minus x and you can multiply with x power 4, you will get x power 5. Is it the least power of x? Is it the least power of x? Think, is it the least power of x, or is there any other least power of x? You have to think about it. Dear students, minus x square, x square term, if you add these two, you will get minus x square. Multiplied with minus x square, you will get x power 4. That is the least possible power of x in the numerator. What is it? Minus x square by 2 minus x square by 2 is minus x square. Minus x square multiplied with this person will create x power 4 term. That is the least power of x in the numerator. In this concept I told you, the least power of x in the numerator and the least power of x in the denominator matters, correct or not? What was the least power of x in the numerator? least power of x in the numerator is x power 4. If you want the answer to be finite, then the least power of x in the denominator also must be x power 4. So therefore the least power of x in denominator, dr means denominator, is also must be x power 4. Then only your answer will be finite. Okay, now you can once again listen to the previous questions to have a clarity about it. Okay, the least power of x in the numerator and the least power of x in the denominator should be same. Then only your answer will be finite. Okay, now so the least power of x in the numerator is x power 4. Therefore denominator also must be x power 4. So what is the value of n? Therefore n value is equal to 4. Carefully once again, if you want, go through the explanation once again, you will understand why n value is 4. Okay now, so that's it dear students about the questions on limits using expansions. If there are any other models in your reference book or objective book, do solve it and let me know if you have any doubts. So and do solve the questions which I told you to try and check whether you're getting the answers or not. That's where you learn, and most importantly practice it. The next topic is limits using trigonometry, limits using logarithms and exponential forms. Those concept will be very easy compared to expansions. See, it's not necessary that every time I'll use the expansion if we see log x or e power x or cos x sin x etc. It's not needed. Okay now, so the upcoming concepts will make the limits containing the trigonometric functions, logarithmic functions and exponential functions easier. Instead of using expansions itself, we will learn how to get the answers. So we will learn that in the next videos. That's it for this video. So I hope you understood the concept of limits using expansions. So let me know what you feel about this video in the comment sections, and if you have understood this topic, like the video, share it to your friends. See you all in the next video. This is M. Sandeep Kumar.